So I just wanted to do a quick tutorial on this Leetcode problem here. So I'll read it out to you. It says, in an alien language, surprisingly, they also use English lowercase letters, but possibly in a different order. The order of the alphabet is some permutation of lowercase letters. Given a sequence of words written in the alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically in this alien language. I'm sorry, that's lexicographically, similar to lexicographically. So here we're given an example. It's words, and it's just a vector of words, and we are given an alien alphabet. And here it's true because this word is lexicographically less than this word. So I'll go ahead and just explain that here using the English language. Like if we said, is Alex, is that word greater than zebra? So it actually is not greater. Zebra is greater because zebra starts with a Z and this starts with an A. So it's automatically greater than. So this is false. And then if we do it the reverse way, then this would be true because zebra is greater than Alex. And we do have the cases when they're equal as well. But in this problem, they're only looking for if and only if the words are lexicographically sorted. So from smallest to greatest. Technically sorted would allow for the same word. So it should be fine. So what I want to do here is define my own operator because in C++, which is the language I'm coding in right now, it you can totally do something like this, like and just compare it with zebra, and it'll tell you if it is or not greater. But obviously, that would not work here because this is an alien language. So we have to define our own alien language. Obviously, there's many different solutions to this, but I'm gonna go with my solution. So I'm gonna do an unordered hash map, and we're gonna go with chars and ints. We're just gonna call it M for map. All right, and what we're actually gonna do is associate each of the characters with a number. That way we can know which is greater than the other. So here, our alphabet for the aliens that they're talking about in the problem is order. So we're going to traverse through that and we're going to put the key as the character, and that is going to be equal to a counter. I have to start a counter. All right. Then we're going to say is equal to counter, and then we're going to increment it. So at each step, we're going to increment our counter. So each subsequent letter will be in the alphabet. So conveniently here, they did give us just ASCII characters, so that's not really a problem. So after we do that, we're going to go ahead and define just a lambda function. And I'll just call it compare. I am going to be passing by reference the items that I'm using in here. I'm going to say const. So we don't want to modify and we're going to preserve those items. So we're going to say constant string, which is the data type. We're going to pass by reference A, and the same thing for B. We'll just name this B. All right, now we can go ahead and define this. I'm going to say size t n is equal to the minimum of a dot size and b dot size. So I'll just explain what that is here. So let's say we have the same two words. So we have Alex, which is 1, 2, 3, 4 characters long, and we want the minimum of these two, 4, and this one is 1, 2, 3, 4, 5 characters long. So the minimum is 4. This is going to be our n is equal to 4. And that's all we're doing with this line. It's just an example. Okay, so now that we have that, we're going to go ahead and traverse through the minimum amount of times that we need. So we're using size t in case one of them is very large. And we're going to check every single character in there that we need to compare. So this is where we're going to take advantage of our hash map and where our hash map comes in benefit. Every check here to our hash map is O of 1. So it's pretty fast in that respect, at least. So we're going to create a temporary int. We're going to call it x. And we're going to say access m at the index of a at I. So remember, a is a string, and strings are composed of characters. And we're checking each character here. If the characters are the same, then this will take almost all of them to complete, or all of them. But if they're different, it's not gonna take long at all. So if the first letter is different, for example, if A is different from W, then it'll only do one. So it doesn't have to go through every iteration. Once we find one that is less than the other, then we can go ahead and return that they're not equal, and we know which one is greater at that point. So here we are checking strictly less than only. That's important. All right. So now that we have them, let's compare them. Right. So we're going to go ahead and compare if the x is greater than or actually if they're not equal, to each other, then we're going to return the comparison of x and y. If x is less than y. All right, and just to put that into perspective, what we're saying there is back to our Alex and zebra example. So we are saying a, we're assigning it an integer based on the hash map that's based on the alphabet that we were provided. So we're saying, for example, if it's the number 5, and then z might be like the number 7 in our hash map. So we're saying is a greater than 7, or 5 greater than 7, or 7, excuse me, or the number 5 greater than z. These all mean the same thing. These are all equal to each other. All right. So That's basically it for this one, actually. And if they are all equal, then we're gonna go ahead and handle if they have like a exact prefix case, like if the the actual word apple and then apple plus are concatenated in two different things. We need to handle this case, like in case something this happens, um, like John. We're comparing it against John Thin. So as you can see, they both share. And remember, we're only getting the minimum. So we're comparing only these. So if they're all the same, we'd never even check these. So we need to check these and make sure that the bigger one gets the win, basically. So we're going to return whichever one is greater. So we're going to return A dot size is less than or equal to B dot size. And that'll essentially return the bigger one in case they're all the same, the ones that we check at least. We could check for the biggest one, but then we'd be trying to access things that are out of bounds, so that wouldn't be good. Oh, and I just realized I put here n plus plus. That should be I plus plus there. And honestly, that should do it. Now we just need to terminate our line statement there. Oops. So here we're comparing. We started the hash map. We initiated the counter. Now we're going to compare. We're going to use this string to compare in here. So we're going to say for int I is equal to 0, etc. I'm going to go ahead and define size. That's going to be equal to the size of the actual words, like how many words we're comparing. So our size of our vector here. Okay, and what we're going to go ahead and do is just compare the two words. It's just that simple. So if the function was called compare, if compare, and we're going to pass in the two parameters, the vector is called words, so words at I, and then words at I plus 1, if this is equal to false, I mean, let's add another parentheses there. Now I'm going to show you what we're going to compare now. So basically we're giving the words array, which is, for example, apple, water, and then like a pen, and then mouse, just random words is what we're given. And first we're going to compare these two with our function. So remember, in our function, this is A and this is B, and this is our first iteration. And then in our next iteration, this is going to be A and this is going to be B in our next iteration. And then in our next iteration, this is going to be A and this is going to be B. So where B is this one, A is this one, here B is this one, A is this one, B is this one, and A is this one. And that's essentially it till we reach the end. So in order to accomplish this, I actually have to do size minus 1. Yep. So if we get the false here, we're going to return false. Otherwise, we're going to return. I'm sorry, this should be true. All right. So if they're all lexicographically sorted, I do believe that should work right there. I'm going to check our test. Looks like I forgot the parentheses here. Size. All right. And this is some of the examples that we were given. This is the alien alphabet that they were talking about, and these are the words that we were tested against. Same thing here. Same thing here. Now we're gonna run it against even more tests. Okay, great. So I did do pretty good here. So I just want to recap. So we were given the problem to take in alphabet that we are given, a brand new alphabet, like a new language basically. And we're giving a series of words, and we are asked to check if all of the words in the series that we're given is lexicographically sorted. And we accomplished this by creating a hash map, and we filled that hash map with the alphabet that we were given, and we assigned a number to each character in that alphabet. We assigned a number to able to track its position in the alphabet. And then we took advantage of that by using this compare here to compare every character in each of the strings that we are given, so each word. And we just go ahead and compare those, and then take our words vector and compare them here. So here we're comparing characters, and here we're comparing the words. And that's how we were able to solve this problem, by essentially defining our own alphabet in a hash map. And we essentially implemented what's already inbuilt into C++, which is the comparison. But this is a pretty fun one here. So you do get to learn about how character mappings work, and that's why I enjoyed this problem. But again, thank you for your time. If you have any questions or anything, just let me know. The next time I come across this problem, I'm going to try to improve my memory efficiency. See how I may be able to get that down somehow.